Today we want to take up a very interesting segment of organic chemistry. It's dealing with polymers. We're going to look at what polymers are and some of the uses of polymers, look at polymer structure, some of the properties and reactions of polymers, and then we can see how valuable these compounds are. Polymer is a long chain of smaller molecules hooked together in a repeating fashion. So we're dealing with long chemical chains to start with, and we're dealing with molecules that repeat in terms of the structure. Poly means many, and mer means unit, so polymer is many units. There are natural polymers that we know about. Cellulose and starch are polymers of the molecule glucose. Starch is in food, cellulose is in wood. Other natural polymers, cotton, wool, silk, all of these are natural polymers that we can find around us. Synthetic polymers, which means that they are made by human beings, nylon, polyester, polyethylene, all of these are chemical products that we have created. Here's some natural polymers, cotton and the cotton boll, silk, cellulose, all of these are found in nature. And then just a couple of examples of the synthetic polymers. Polyethylene water pipes, which are easier to work with and more resistant to being buried underground. Nylon in shoes. Nylon is used in a wide variety of materials. Polymer structure is a sequence of repeating units connected by covalent bonds. Okay, so these are covalently held together, so they're not likely to come apart unless there's a chemical reaction. Individual unit is called a monomer, mono meaning one and mer meaning unit. Many different monomers can be used, a wide variety of them. If all the repeating units are identical, the polymer is called a homopolymer, homo meaning the same. If different repeating units are used, then it's a copolymer, and that gives us an indication of the structure. The monomers have to have a reactive functional group in order to form a polymer. So there's got to be the ability of the monomer to react with another compound in some way before you can begin a polymer. Here's some examples of monomers. Polyethylene monomer, or the Kevlar monomer. Kevlar is used in vests, bulletproof vests, things like this. Vinyl alcohol, methyl methacrylate. These are different materials that we can use, and you see the monomer indicated in the vinyl and the methyl methacrylate. The monomer is indicated in red, and you can see how these monomers link together to form polymers. Their monomers are found in page 188 of your book. Ethylene monomer in polyethylene. This illustrates a homopolymer because all of the monomers are the same. They're all ethylene monomers. On the other hand, Kevlar is made up of a copolymer because Kevlar has two different monomers in it, and so that's a copolymer. Is the polymer linear or branched? A linear polymer, if we synthesize it like this, will be strung out or just coil up as a random coil. A branched polymer is where the monomers react at different places in the molecule and build up these complex branches and chains, and the behavior of these polymers is quite different. Now, cross-linking can occur in polymers based upon the availability of a functional group. A double bond, an amine, an alcohol, carboxylic acid, a functional group hanging loose on one polymer chain can react with a functional group on another polymer chain, and you get cross-linking, so you get a more complex structure that way. Polymer addition reactions, these connect polymers containing double bonds as a functional group. And they start with the formation of a free radical. This is a molecule that has one unpaired electron. and these free radicals are extremely reactive. So the unpaired electron forms a carbon-carbon single bond with a carbon-carbon double bond group by taking one of the electrons out of the carbon-carbon double bond and forming a covalent bond with that. Now that leaves the other electron free in the double bond, so we've generated another free radical, and so that's free to react again. Here's a diagram of the situation. A free radical, an initiator molecule of some sort, will interact with an ethylene monomer and will form a single bond, generating a free radical electron on the other end of the monomer, which can then attack another monomer and continue to build on and on to form, in this case, to form polyethylene. Now you can get side reactions in addition reactions. You can form uh, free radicals in the middle of a compound, and they can start to build branch points. And you can also get termination reactions where two free radicals react with one another. They form the carbon-carbon double bond or single bond, but they have not generated a new free radical, so the free radical reaction in that molecule stops. So you can get polymer branching through free radical reactions, or you can get termination of the reaction. Typical condensation reactions take place between two different types of compounds, two different monomers. In this case, you form ethyl acetate. This is an example of a condensation reaction. The acetic acid and the ethanol form ethyl acetate, the ester. You can form an amide through the reaction of an organic acid and an amine. We've seen these reactions before. So if we're synthesizing nylon, for example, we use adipic acid, which has a carboxylic acid at each end, and we use hexamethylene diamine, which has an amino group at each end. And so you form a condensation reaction, and you continue to build that chain as the reaction proceeds. If we're making polyester, we've got a similar situation. We have ethylene glycol and terephthalic acid, so we have the reaction between an alcohol and a carboxylic acid, and the same process can take place and continue to build the polyester that way. Okay, in brief, we've talked about polymer structure. We've talked about what polymers look like. We've talked about the difference between homopolymers and copolymers. We've discussed linear and branch structures, and these are important in terms of polymer properties, which we didn't discuss today. But linear and branch structures are very important for how the polymer behaves in real life. We've talked about addition reactions, free radical reactions that couple one monomer to another, and these monomers are of the same structure. We can get branching in these kinds of things, and we can also terminate the free radical reaction when two free radicals react with one another. And we've talked about condensation reactions where two different functional groups will react. The monomer will have functional group of some sort and usually have it on either end of the molecule, and it will react with a functional group of another type on another monomer and build a chain that way. Okay, thank you for being with us, and we'll talk to you later.